substitution. And maybe we'll get to the third type, which is called elimination, depending on how much we get through. So have you seen these before? Have you heard of these before?
Not 2 and 3.
Okay. Well, the nice thing is we're going to start out very, very easy because that's the best way to learn. Get some easy problems, build some confidence, get to the more difficult stuff. So this is a system of equations right here. This is a system of equations. System meaning two or more. They're linear equations, and we're going to solve. Now, the first type of substitution, like within substitution, there's a couple of like sub cases. The first one is you just set the equations equal. So you set 5x plus 3 equal to 4x plus 1. That's what I mean by set the equations equal. And look, we just did that, and guess what? It worked. Okay. There's no y. The whole point of the system is you have two variables, you get it down to one variable, and then you can solve it. So this is something that we've solved before. Does this look familiar to you? Like if I get rid of the system and just have this, does this look like something we've solved before?
Yeah.
Yeah. So you move from the smaller to the larger. So I'd like you to try solving this, please. You have an answer for me?
Not yet.
Okay.
One x equals -2.
X equals -2. Very good. Okay. So unfortunately, though, for a system of equations, there's two numbers you got to give. The first is x, or the first variable, and then you got to find y. Okay. Now, Y is 5x plus 3, y is 4x minus 1. So what you do is you choose an equation, and in this case, it doesn't matter, but you put that x value in for x. So 5 times -2 plus 3. 5 times -2 is -10 plus 3 is -7. Okay, now if you went with the other equation, you might be wondering, well, does it give the same result? Well, it's supposed to. Okay, meaning like if you do it right, it should give the same result. 4 times -2 is -8. -8 plus 1 is -7.
Okay.
So your answer, and this is very important, your answer is an ordered pair. Your answer is -2 comma -7. Or you could write x equals -2, y equals -7, like that. All right. It depends on the instructor. It depends on what they want, frankly. Like, okay, you ready to do another one?
Yes.
Okay. I like that. I like the excitement. Even if there is none. All right, so same thing here. Same thing. You've got a system of equations. It's already solved for y. Yay. Okay. What we're going to do then is set the equations equal to each other. You're going to set 3x minus 4 equal to -6x plus 5. And then you always move the smaller to the larger. All right. So in this case, you're going to move the -6x over to the 3x.
Okay. Nine x equals 9.
Okay, keep going. You got to solve that for x, get x by itself. So you have to undo that multiplication by 9.
1.
Okay, so x equals 1. Okay, now it's your choice. You can use either the first equation or the second equation to solve for y. Sometimes one is better than another, like it looks better to you, or you like the steps better. Doesn't really matter to me, but pick one equation or the other and work it out if you don't mind, please.
Okay. It equals 1.
Y equals 1? Which equation did you use? The first one or the second one?
First one.
Okay, so we got y equals 3 times x, so 3 times 1 minus 4. 3 times 1 is 3, minus 4 is -1. So we got x equals 1 and y equals
Negative 1.
-1. Okay. All right, so is kind of the setup clear now? You set the equations equal, you solve for the variable, then you put it back into the other.
Yes.
Okay, so just to kind of step through this, what I'd like you to do here is set the equations equal, just like I've been doing. Solve for x though. Give me the value of x before you find y, just because if you get x wrong, then y is automatically wrong. But go ahead and solve for x for me, please, just like we've been doing.
X equals 2. -2.
Yeah, which one? Just to be clear, is it 2 or -2?
-2.
All right. Yeah, I agree. X is -2. Good. Okay, so now choose one equation or the other. Doesn't matter whichever one you feel better about, and solve for y, the y value.
Okay. It equals 9.
Y equals 9, you mean?
Yeah.
Okay, good. Very good. So again, when you present your answer, make sure you present it in a way where you're either writing the variables or as an ordered pair. Sometimes you'll see it that way.
Okay.
All right, you're doing really well. The next kind of type of problem that you'll see here, which I don't know why I don't have that open. So occasionally it's reversed where the equations are actually solved for the other variable, in case x, which maybe looks awkward at first. Like, I don't know. I mean, maybe for me, like, I mean, I look at the stuff all the time. So for me, it's no big deal. We're used to it being y equals. Now it's x equals. You still do the same thing. You still set the equations equal to each other. Okay. It's just this time you're solving for y, not x. Okay. But you still move the smaller to the larger. Okay. So you have 16 equals 8y. Divide by 8, y equal 2. So this time you get y first. Okay, all the other problems we've been doing, you got x first. Same thing that you go back to one equation to the other. Now, I think the second equation is better. Why might that be better? Because it's 3 times y. It's not, there's no negatives. There is a subtraction, but like it's better when you kind of keep things positive. So x is 3 times y minus 9, or 3 times 2 minus 9, which ends up being 6 minus 9, which is -3. You still do it x comma y. It's always x first, then y. So -3 comma 2, like that. So it's really the same problem. It's just you're solving for the other variable first.
Okay.
Is that okay?
Yes.
All right. So let me give you one to try, and then we'll truly move on to the next style of question here. So go ahead and solve for both x and y in this, and let me know what you come up with.
X equals -10 and Y equals -3.
Okay, so let me, sorry, let me work it out here just in case you want to look at it later. I heard something I didn't quite like. Just want to confirm that. So in this case, you're going to move the 2y left because it's smaller. Would you agree that 2y is smaller than 3y?
Yes.
Okay, so then this becomes y minus 7 equals -4, or 1y. Hopefully that you got that there. But now you add 7. So you add 7 and y equals 3. And I think I heard something a little bit different than that. Yes, no, maybe.
Yeah. I
Okay.
see where I went wrong.
Okay, so now very important is now that we've kind of got one of the variables right now, let's go back. It doesn't matter which equation you use, but give it a try there. And
Y equals 2.
you already have y. You're solving for x.
Oh, X equals 2.
X equals to, yeah. And it's really important because when you put the numbers, let's just say the answers were ordered pairs. The ordered pair 2, 3 is correct, but 3, 2 is wrong. And so the order really does matter here. All right, is that you want to do one more like this, or do you feel like you have it?
I feel like I have it.
Okay. All right, so the next style of question here, we're still in the land of substitution, meaning all these are substitution problems. You have one equation in what's called standard form, or roughly standard form. It doesn't have to be perfectly standard form, but roughly standard form. And the other one you typically have is solve for a variable. Okay.
Okay.
So if you remember from last time we talked about standard form, the second one's actually slope intercept form. Now you take the one that's solved for the variable and you put that back in. Like that. You put it back in. So instead of y, you're going to write minus 5x plus 6. So that's 2x plus minus 5x plus 6 equals minus 3.
Okay.
Okay. So now it's an equation in one variable. So unlike the last one, though, it's got variables on the same side. So you first combine like terms. Okay. So what is 2x plus minus 5x?
-3x.
Negative 3x plus 6 equals negative 3. And now this is a two-step equation. So you solve it the way you solve any other two-step equation. You first undo addition and subtraction, then the multiplication and division. Okay, so I'd like you to solve this for x for me, please.
X equals 3.
Okay, so you subtracted 6 from both sides. Minus 3x equals minus 9. What do you divide by now?
-3.
Negative 3. Does that change your answer at all?
X equals 1.
Nope, -9 divided by -3. The negatives cancel. 9 divided by 3 is positive
3.
3. Okay. Okay, now very important. Now that you got one variable, let's go back to look at the system. Okay. You know that X is 3. Okay, that's great. While you can use either equation, you should use the one that's already solved for Y. You should put X into that equation there. -5 times 3 plus 6 like that. What is -5 times 3?
-15.
-15 plus 6 is -9. So that's Y. Okay, so you've got X and Y. X is 3. Y is minus 9, like that.
Okay.
So you could use the first equation to solve for Y, but why not use the one that's already solved for Y? All right.
Yep.
Okay. Wait, is this the? Okay. All right, so let's do another one here. I guess I didn't sniff another one in. Okay. Let's do another one. Steps are kind of the same. You're just going to take the equation that's already solved for the variable. It's already solved for Y. You're going to take that and put it into the other one. So the first equation solved for Y, the second one's in kind of standard form. So it becomes -7x plus. Now, instead of Y, it's 5x minus 2 equals -6. Like you imagine like all that goes in for Y, rewrite it that way. And then now it's just an equation, and meaning X is the only variable. That's really good news because that's something you know how to solve. We've been solving those for a while now.
Yep.
So we got -7x plus 5x. What does that become?
-2x.
-2x minus 2 equals
-6.
-6. Okay. Why don't you solve it from here for X for me, please?
Okay. X equals -2.
Let's look at this. Yeah, I think you got a sign error again. So when you add 2 to both sides, -2x equals -4. So a lot of sign errors today, which is unusual for you. You're usually very spot on. Hopefully everything's, clear because you're dividing by -2. And so X equals 2, +2. I think you said -2. Yeah, that sign means a lot. There's a lot of, difference when you have different sign. Is that okay?
Yes.
Great. So now we're going to go back and we have our choice. We have choice of equations. Okay. But we really should use the one that's already solved for Y. So we should use this first equation, put the 2 in for X. The Y is 5 times 2 minus 2, 10 minus 2, which is 8. So your final answer is 2, comma 8. Right? You got to be comfortable putting that back in. If you put -2 in and don't realize that it isn't, you don't know that it's wrong, you end up getting the wrong answer here. And sometimes you will see that on tests where the wrong answers are there as multiple choice.
Okay.
Okay, let's have you try one now. I want you to first solve for X. So give me that X value first, please. Just like we've been doing though. You're gonna substitute, solve.
X equals 2.
Yes, X is 2. Very good. So why don't you use that second equation there and solve for Y, please?
Y equals 2.
Yes, Y equals 2. That's really good. Okay. Okay, so let me do a couple problems here just to kind of help here. So just like the previous set, you can also have where it's flipped. Like it doesn't always, it's not always the case that it's Y that's solved for. It could be X that's solved for. So in this problem, X is solved for in the second equation, and that goes in that position. It ends up being minus 2Y minus 7 minus 4Y equals 5, like that. And then you're solving for Y now. Now you still combine like terms. So minus 2Y minus 4Y is minus 6Y. Minus 7 equals 5. Okay, so just like before, combine like terms. This time though, they're not quite lining up, but that's okay. And then it's a two-step equation. So you undo subtraction by 7, you add 7 to both sides. Minus 6Y equals 12. And then you divide by minus 6. So Y equals negative 2. Now, again, just like the previous problems, you got to go back and solve for the other variable. So you go to the equation that allows you to do that easiest, which is the second equation. So in this case, it'd be like minus 2 times minus 2 minus 7. Minus 2 times minus 2 is 4. 4 minus 7 is minus 3. So again, you write X before Y, minus 3 comma minus 2, like that.
Okay.
So really it's the same, right?
Yep.
So, I mean, you just got to be careful, it's very, um, yeah, you gotta be careful. Um, okay, so the next style of problem here, we'll move to something new here. It looks, at first glance, it looks the same. You've got y equals, you've got the y in the other equation. So you're going to take what's here and you're going to substitute in for y, okay? But this time there's a subtraction in front, okay? And what that really means is there's this implied parentheses around the variable. Okay, so what that means is it's 7x minus parentheses minus 5x minus 3 equals minus 9. So instead of just putting this subtraction in front of the minus 5x, it's the whole thing that you are subtracting. Now you might wonder, well, why didn't we do that in the previous problems? Well, when it's plus doesn't affect parentheses. Do you remember that from earlier lessons that we've done?
Kind of.
Kind of. Okay. Well, the point is, like, let's just say we went back to one of these problems and we put a plus. Sorry, I'm trying to find where we actually had one. Okay, like right here. If I put parentheses around this, that doesn't really matter because the plus doesn't affect, the parentheses aren't affected by the plus, you would just drop them. But because it's a minus in this new problem, you have to treat the variable like it's in parentheses, which means you have to distribute the negative like that. All right, so now this becomes 7x plus 5x plus 3 equals minus 9. And now it just looks like all the other problems we've been doing. Is that okay?
Yes.
Clear? All right, so then just like before, you combine like terms. You undo addition and subtraction, and then you undo multiplication division. So 12x equals minus 12, divide by 12, divide by 12, x equals minus 1, like that. So the key, the challenge here is that when the variable is subtracted, like we just talked about, you have to be very careful that you substitute in like that. So let's look at another problem here. I know this isn't super exciting, but we're almost through. Kind of the same deal here. You got one of the variables solved for, y equals minus 4x plus 7. But in the second equation, minus 4x plus 7 is going in for y. So again, it's minus 5x minus parentheses minus 4x plus 7. All right, so from here, you distribute the negatives in. It's a minus 5x plus 4x minus 7 equals minus 11. And then combine like terms. So you got the minus x minus 7 equals minus 11. All right. And then you just continue solving like we've done, a bunch of times. You end up getting minus x equals minus 4. It's really a -1. You divide by -1 and you get x equals 4. All right, so this progression is, very repeatable what we've been doing. You do this over and over again. Then you go back to one equation or the other and you solve for the other variable. So we got y equals minus 4 times 4 plus 7 minus 16 plus 7 equals minus 9. So we have 4 comma minus 9 like that. Is that okay?
Yes.
All right. So, these are very much, we got, but you got to know, you got to be okay with each type of problem you're going to see. You're going to see a bunch of this, same type here. Again, you're going to take this and substitute in there. So it looks like this: minus 2x minus 3x plus 10 equals minus 5. All right, so I'd like you to try solving this from here for x, please. I'll check back with you in a minute here. All right, how are you doing on this one?
X equals 5.
X equals 5, good. Yep. And then go to that second equation there, put that in for x, and go ahead and tell me the value of y, please.
Y equals -5.
Good, really good. Okay, good lesson today. We're going to go ahead and stop right here.